Alrighty guys, welcome to our second review video. Let's get going. So this packet is mostly about completing the square. However, remember that we do not have to complete the square in every question, just on the problems where I'm asking you to complete the square. There's actually going to be questions later on where you'll be able to factor if you want to, or complete the square. And there's going to be a third method we will learn after October break. Anyways, let's get going. So step one, to all these completing the square questions, is going to be putting all of the x's on one side, all of the not x's on the other. So we're going to go ahead and subtract 4x on both sides, and subtract 15 on both sides as well. When we do that, we get x squared plus 16x equals negative 15. Let me do some crossing out there for us. So somebody asked me to slow down on my videos, and it looks like I actually need to make sure that my pen is writing darker too, because I can't quite see what I'm writing there. Okay, so hopefully I slow down enough, but feel free to give me feedback otherwise. Now, like we've been doing in class for quite a bit, we're now going to go ahead and write this 16x off to the side. We will take away the x, divide by 2. So that's what we did there. We divided by 2, and then we squared it. And that's going to give us a total of 64. So we're going to go ahead and add 64 to both sides of the equation. I'm going to do that in a separate line so we can see that. In class, I also said that after you divide by 2, we should put a star next to the 8. You don't truly have to, but it's going to be useful in the next step, because whatever this number is after we've divided by 2 is going to be what this whole thing on the left-hand side becomes. X plus 8 squared. Over here, we need to go ahead and add negative 15 and 64. If you add those guys correctly, you're going to end up at 49. So, just a quick recap, this is called completing the square. I'm going to use letters CTS for this guy. Completing the square is the act of dividing by 2 and squaring and adding this to both sides of the equation, or adding and subtracting from one side of the equation. Now we're going to go ahead and take the square root of both sides. So I'm showing extra work on this very first question, but I won't show as much in the future questions. Anyway, took the square root of both sides. Really, really important. You've got to remember your plus or minus sign. Maybe make a note for yourself off to the side. Take square root means plus or minus. There are two answers whenever you take your square root of both sides. You really, really got to make sure you do that, or you're going to forget and get questions with one answer instead of two. Anyways, when you do the square root of something squared, the square goes away, square root goes away, and you're left with just the inside. And over here, it happens to be the case that the square root of 49 is a number we're able to use. In fact, it's 7, so we're going to write plus or minus 7. After that, we're going to go ahead and subtract 8 on both sides of the equation. So you get x equals plus or minus 7 minus 8, which actually leads us to two separate answers. So I'm going to go ahead and write them over here. Please note, it's actually customary to write this negative 8 first. So I'm first going to rewrite it that way, just because that is the normal way of writing it. You don't have to, but you'll see why we do it that way. Actually, when we get back from break, it's going to make more sense why we write it that way. Anyways, we got negative 8 plus or minus 7, so x equals negative 8 plus 7, which is negative 1. And x equals negative 8 minus 7, which is negative 15. And there are two correct answers. Let's just write them up here so we can see nice and neat what those two answers are. Awesome. Let's move on to number 2. So number 2 is a little bit more difficult only because we have fractions. We have the same exact step first as the last one. We'll put all the n's on one side and all the numbers on the other. So I'm going to go ahead and add n squared to both sides and add 11 to both sides. Again, I'm leaving that space. Remember, if there's not a number written in front of something, there's an invisible 1. So we're going to go ahead and put that 1 in there for us just to help out. And man, my screen's going nuts. I'm going to try to fix it. Hopefully that fixed it. Now we're going to take that negative 1n. We're going to take away the n. We'll divide by 2. We're going to write that as 1/2. Please note, on your calculator, in the event that you decided that you did not want to do that 1/2 part on your, oh, should we move it down here? You don't want to do that 1/2 on your calculator. What you can do is you'll type in that negative 1 divided by 2, and it will give you that negative 0.5. But you can make it convert to a fraction for you. You'll just hit math, enter, enter, and it converts it to a fraction for you. The next step is to square. When you square something, you're multiplying it by itself. But on the calculator, we can do this really, really quickly by just hitting the squared button immediately and hitting enter. Gets you 1/4. We're doing negative 1/2 times negative 1/2. That's going to be 1/4. We also put a star after we divided by 2 and before we squared. Now we're going to be adding that 1/4 to both sides of the equation. We're going to go ahead and rewrite the left-hand side. Again, that 1/2 right there, negative 1/2, came from the star. And over here, if you've already typed this in your calculator as a fraction, it's really, really easy to add fractions. You just do 11 plus that answer. So to get that answer, by the way, I hit seconds and then the minus sign, and it gives me the answer to the previous question, which was 1/4. You also could have just typed it all the way in, but either way we get 45/4. Now we're going to take the square root of both sides of the equation. Do not forget your plus or minus sign. But please note, the square root of 45/4 goes over both the top and the bottom. So I'm going to kind of do this off to the side so we have more room to write our answer later. But the square roots of 45/4 is the same thing as the square root of 45 over the square root of 4. And the square root of 4 is 2. So I'm going to write this as plus or minus square root of 45/2. Not truly a requirement for this class, but definitely good practice to write. Now I'm going to go ahead and add 1/2 to both sides and get n equals 1/2 by adding 1/2 to both sides. Square root of 45/2. And now I have two separate answers. We have n is 1/2 plus square root of 45/2, and n equals 1/2 minus the square root of 45/2. Easy enough. Now, going on to this next question, we're going to have a little bit more of a tricky situation. So the reason why is because we have this number in front that we're going to have to deal with factoring out. First of all, I'd rather it be a positive number than a negative number, but I'm not actually able to move it around just yet. I'll show you that on this question because there are going to be problems when we graph where we can't move it around. So I'm going to go ahead and keep it negative on this problem, but we actually don't have to. We do need to rearrange it though. We need to put it first. All I did was rearrange those numbers. I didn't actually do any math. I just moved things around. And now we have to factor. What I mean is we have to factor out this negative 6 from these two, but not from the 37. When you factor something, you're dividing. So negative 6 divided by negative 6, that's 1. 12 divided by negative 6, that's negative 2. Leave some room for yourself. That 37 does not try to get divided by negative 6. Just like in those previous questions, we're now going to take that negative 2x off to the side. We're going to take away the x. We'll divide by 2, put a star, and then square. And we're almost done. Got to add 1 here. But really key idea. We added 1 there. Oh, actually, I'm sorry, guys. I forgot something. On other questions, I had moved this 37 over. You know what? I'll do it correctly on this problem over here where I move the number over. But it actually doesn't matter. We'll still get the same answer. So let's go ahead and do it this way. Without moving the 37. Move the 37 later. Not a big problem. Actually, I'm moving it now. I'm sorry, guys. This should have been over here. This should have been a negative 37. Okay. Should have subtracted it over. That's my fault. Anyways, back to where we were. We factored out the negative 6. We divided out here. We did 12 divided by negative 6 to get the negative 2. We did the negative 2, did completing the square, took away the x, divided by 2 and squared it, put the plus 1 here. The deal is we didn't actually add 1. We actually subtracted 6, because negative 6 times 1 is negative 6. So we're actually going to subtract 6 on the other side. Like so. Now we're going to continue. Negative 37 minus 6 is going to be negative 43. Nothing changed on the right. After that, we need to divide both sides by negative 6. If we divide both sides by negative 6, we end up with positive 43 over 6. And now I'm going to take the square root of both sides. This number can't really reduce at all. It's super duper nasty, and we're just going to leave it that way. And then we're going to add 1 to both sides and write our answer separately. So we get x equals 1 plus the square root of 43 over 6, and x equals 1 minus the square root of 43 over 6. I like to give the warning that not all math classes or math tests, including the SAT or ACT, will accept square roots in the denominator. So if you needed to, there is a way to get rid of that square root in the denominator. What we're going to do, this is optional by the way, so you can just skip to the next question if you don't care, just fast forward the video. We can rewrite the square root of 43 over 6 as the square root of 43 over the square root of 6. Multiply the top and bottom by the square root of 6. Turns out that 43 multiplied by 6 there is going to be 240 plus 18, which is the square root of 258, all divided by 6. So that's how the answer would be written on the SAT or ACT as opposed to this up here. I'm going to do this problem slightly differently actually than even the way I've done it in class. This only works on completing the square questions with equal signs where you're able to move things around. But we're actually going to divide really, really early. It's optional, and you can't do it on the later questions with the graphing, but it actually makes the problem a lot easier. So we're going to go ahead and do that. In order to do this, we're first going to go ahead and move everything with a letter again to one side, everything without a letter to the other. So we're going to subtract 8 here on both sides, and then we're going to go ahead and add 19m. So that goes away, that goes away. Negative 17 minus 8 is negative 25. And that equals negative 9m squared. And what's 3 plus 19 is 16. Just like that. So, do I really want to teach it that way? I don't think I do. Because then I have more fractions to deal with, and you guys won't like that. Maybe we end up with fractions either way. Oh, this one's ugly. Alright, I'm teaching it that way. We're dividing everything by negative 9 early. Alright, so what we're allowed to do, if you ever want to, you're allowed to divide every single term by the same number in a problem. So I'm going to go ahead and divide every single term here by negative 9. You're allowed to do that if you want. The end goal of this actually prevents us from having to factor in the future. So what I'm going to write here is I got 25 over 9 equals, because the negatives canceled, just m squared, and now this is our nasty fraction here, 16 over 9m. That's unfortunate. And now we just have to complete the square. let's just do the whole thing on the calculator because we have such nasty numbers. Please note, you do not have to do this on the calculator. You are able to do this by hand, but you don't need to do it by hand. Maybe I should show you how to do it by hand before the calculator. Yeah, let's do that. So just this negative 16 over 9m part. All right, so the by hand part, we're going to first take away the m, just like normal. Same exact thing we've been doing. Then we're going to divide by 2. Dividing by 2 is the same thing as multiplying by 1/2. But if you divide by 2, you can actually just divide the numerator by 2. So in this question, we can just get negative 8 over 9. And that's the number we're starring. And then we square. Please note, if you don't want to do this by hand, you can make the calculator do it for you. So we're going to do, just like before, we're going to hit negative, and we're going to hit alpha y equals enter. Alpha y equals enter gives us this fraction. We'll type in 16 over 9. Now we know we need to divide by 2 for our first step, because that's where we are. We're right here. Divide by 2. And that's going to give us the negative 8 over 9, just like I was saying. Please note, if you wrote 16 over 18, you wouldn't get the wrong answer. You would just have bigger numbers that are more annoying to deal with. After that, you're going to hit squared, and then you get the 64 over 81. We're going to want that in our calculator for later for sure, because now we have to add 64 over 81 to both sides. Because we add 64 over 81 to both sides of the equation, the right-hand side is nice and easy. We already have the starred version. And you could just add fractions like you normally do. You know, multiply top and bottom by 9. You'll end up getting, what is that, 225 plus 64. You'll end up getting, let's see, 289 over 81 equals this whole thing. Or make the calculator do the work for you. 64 over 81 plus 25 divided by 9. You add the two things together. Oh, it gave us a decimal. That's because I didn't type in the 25 over 9 as a fraction. But you don't want to have to do all this extra work. So what you should do is hit math, enter, enter, and it will convert whatever it is into a fraction, just like we did earlier. Anyways, now we're going to go ahead and take the square root of both sides of the equation. So we're going to go ahead and do the square root. Don't forget your plus or minus, these square roots. When you do that, you're going to go ahead and get, what is that, 17? No. 17, 20, 17. Square root of 289 a number? Sorry, guys. I think it is 17. Yeah, it is. It's 17 over 9 plus or minus equals m minus 8 over 9. Please note how you could do this on the calculator. All you have to do is type in second x squared, and that will give you a square root. And you just type in that 289 over 81. I'm going to be lazy and hit second answer, like I've been doing before. And that will give me the square root of 289 over 81. It's 17 over 9. After that, we add 8 over 9 to both sides. Finally, 8 plus 17 all over 9, because it's a same number, so we can do that, equals m. And 8 minus 17 all over 9 equals m. And again, if you don't want to do that, you can always just do it with a fraction. We just got that 17 over 9. We can add that to our alpha y equals enter 8 over 9. You know, and it will do the work for you. We'll still get the same 25 over 9 I'm going to get right here. And over here, 8 minus 17 over 9. And again, if you don't want to do this, go ahead and grab, you know, your 17 over 9 that you had here. But now that needs to be negative, so we can make it negative. Put a negative in front there. And what are we adding to it? 8 over 9, so alpha y equals enter. We got 8 over 9. Actually, it needs to be subtracted. Easy enough. And how did they do that, by the way? 8 minus 17 is negative 9. Negative 9 over 9 is negative 1. I know that problem was nasty. It's a lot of fractions, but it's exactly the same process. And if you really just follow the process over and over and trust your calculator to give you the correct answer, you're not going to get it wrong. I highly recommend trying this entire problem one more time, off to the side, maybe on another piece of paper, and just seeing if we can do the whole thing maybe on a calculator. Please note on the test, I will most likely not put this on the next test, but I will be putting it on a future test where you are able to answer problems in multiple ways. Anyways, let's go on to the next page. So it says here we need to write each equation in vertex form and then graph. It wants us to label include our x and y intercepts, axis symmetry and vertex, just like that last test. Please note, not all questions have x-intercepts. In fact, the first question does not have any x-intercepts. We're going to see that in just a moment. So it says first means vertex form. This guy means complete the square. That's what that means. Let's go ahead and do it. F of x equals x squared minus 6x. We're putting it in parentheses and leaving some room. Same stuff we've been doing. Negative 6x, negative 6, negative 3. Square it and get 9. Put the little star there. We added 9 here. Because we added 9 here, we must subtract 9 out here. That's where this problem becomes different. Because we can't add 9 to both sides. I can't put a 9 over here. This needs to stay f of x so I can keep graphing it. But we have to add 9 to this side. But instead of adding 9 to this side, we subtract it over here. And now we get x minus 3, remember from the star, squared, plus 3. The point of doing this is, whatever the opposite of this sign is, so that sign's a negative 3, so we're going to change it, our vertex, because that's a negative 3, we're going to write positive 3. That's the x value of the vertex. And the y value of the vertex is literally whatever this number is. Don't change the sign. Exactly the same. So our vertex here is 3, 3. That's actually our first coordinate we can just put on a graph. Nice. And there are no x-intercepts here, and we're going to find that out in just a moment. But let's go ahead and do our y-intercept first. Our y-intercept is going to be 0, 12. And that's not even on the graph. We can't do it. The reason why I'm saying that this is having no y-intercept is this is a parabola that's going to go up. We know it's going up because there's a positive x in front. So it's not going to be able to cross down here. So now what do? We only have this one dot, and we don't have any other coordinates. We do know our axis of symmetry at least. Our axis of symmetry is x equals 3. It's the same value as that vertex. We have this dotted line that goes through the thing. What we're going to do next is we could ask our calculator for help, or we can just start plugging in numbers. I recommend plugging in numbers that are close to 3. That's going to make the problem the easiest, actually. So, for instance, let's plug in 2. If I plug in 2, f of 2, please note I can plug in 2 into the original problem up here if it makes you happy, or you can plug it into this one down here. I'm going to plug it in this one. There's no real reason why I'm choosing that one. I just feel like it. So I plugged in 2 where the x was. 2 minus 3 is negative 1. And negative 1 squared is 1. That's going to give you 4. That means we have the coordinate 2, 4. I'm going to go ahead and start making a table of values for myself, because doing a table of values on this question makes things a little bit neater. So a table of values in this question would look like this. I'm going to run out of room here. I'm going to have to scroll up. We have x. We have f of x, or you can write y if that makes you happy. Please note you do not have to do this table of values. I just like doing it. It helps keep me organized. So I have this original coordinate right here in the middle. I'm going to write 3, 3. There's our vertex. And then we also have a coordinate right above it, 2, 4, which we can graph way up here. Now, because of the axis of symmetry, visually the idea is if I am 1 away on the left here of the axis of symmetry, I'm also 1 away on the right. So I'm guaranteed to have the coordinate 4, 4. Let's figure out another way of thinking about that. A y value has a mirror image of symmetry right here. This 4 down here means on the other side of the vertex, you are also going to have the same y value. You don't have the same x value, though. What happens is the x is 1 away, so the y is 1 away. Now we just need to figure out another coordinate. Let's plug in 1 into our graph. I actually already know what this coordinate's going to be down here without even thinking about it, because I am 2 away from the x here. I'm going to be 2 away from the x here. I'm going to put a 5. Now I need to figure out 1 comma what? Well, I got to plug in 1. Just because, I'm going to plug in 1 into the original equation now. That guy way up here at the top. So f of 1, that's going to be 1 squared minus 6 times 1 plus 12. And if you're too lazy to do it, always do it on your calculator. But 1 minus 6 is negative 5, and add 12 and you get 7. And you get a 7 here, and if you got a 7 there, you get a 7 here. So you get a 1 comma 7 and a 5 comma 7. And now my graph is nice and neat. And there are no x-intercepts because the graph goes up. Let's do the next one. The next one will have x-intercepts for us. But first, we're going to complete the square. So completing the square, we have x squared plus 8x, and those parentheses plus 13. We're going to take that 8x, and now I'm going to trust that you guys can do this step off to the side. You don't actually need to write it all down if you can do it in your head. Divide that by 2 and square it. That means you're adding 16. And if I added 16 right there, I'm going to subtract 16 out here. That's not that bad. And the number after I divided by 2, that's going to be 4. So you don't have to show your work if you don't want to. Not that bad. 13 minus 6, by the way. That's a minus sign. Really ugly minus sign, but a minus sign nonetheless. Again, our vertex is always going to be the opposite of the sign. Here, I'm going to write my coordinates up here. My vertex is going to be at negative 4 comma negative 3. That also means my axis of symmetry is x equals negative 4. It's the same value. Again, it's the opposite of this sign, whatever that is. That's what goes there. So we can go ahead and start graphing that. Negative 4 comma negative 3. And we got a dotted line going down. After that, we want our y-intercept. We're going to go ahead and plug in 0, but again, our plugging in 0 is nice and simple. Our y-intercept is always this guy up here, that 0, 13. So our y-intercept is 0, 13, but that's useless to us because 13 is like all the way up there somewhere, so I'm not going to use that value. And now we need to figure out some more coordinates. But in this question, we're going to be able to figure out the x-intercepts because the graph is going to go up here. Again, it's a positive x squared. It's going up. So to figure out our x-intercepts, we always need to make f of x equal to 0. Please note, if you want to try to make f of x equal to 0 in this question, you can, but you're going to get I answers. You're going to get square root of negative numbers, and you don't really want to deal with that. Anyways, I've set this equal to 0. I'm going to add 3 to both sides of the equation. I'm going to take the square root of both sides of the problem. And unfortunately, I have this plus or minus just like on that previous page, so now I got to subtract 4. You get negative 4 plus or minus the square root of 3 equals x. So my x-intercepts I can write up here. I got 2. 4 plus the square root of 3, comma 0, and 4 minus the square root of 3, comma 0. Well, that didn't even help us. We don't have any more coordinates now. I still have just my 1 dot. What do? Table of values. Make your table of values. Make it nice and neat. Shouldn't be that big of a deal. You can probably make yours neater than mine, though. Anyway, so we start with the very middle value as our vertex, which we figured out negative 4 comma negative 3. And then we want to plug in values close to the vertex. So I'm going to go ahead and plug in this case, I'm going to plug in, I don't know, how about negative 5? Plug in negative 5 right here. So I'm plugging in negative 5 into my equation. I'm going to plug negative 5. I'm going to plug it in again right here. It's typically going to be easier to plug in there. It's not always going to be easier, but that's what I'm doing. Plugging in negative 5 for that x. Get negative 1 squared minus 3. That's 1 minus 3, and that is negative 2. That means you have the coordinate negative 5 comma negative 2. because I was 1 away here, I'm going to be 1 away in the other direction. That's -3, and I'm going to copy that -2. Now I got 2 more coordinates for us. -5, comma, -2. And then we're going to have -3, comma, -2. Now, I really am a fan of pattern recognition. Pattern recognition is when you notice that the problems are going to be the same from problem to problem. And whenever you have an x squared that does not have a number in front, just like this problem, and like it's probably going to be on the test, there's a visual pattern that always comes out. If you notice, in this question over here, I simply went 1 to the left and 1 up here, and I went 1 to the left and 1 up, almost as if it was a straight line at the start of my parabola, and the same thing happened here. But on the next one, I went 1 over and then 3 up. Same thing is going to happen here. 1 over and 1, 2, 3 up. If you want to take the time, you can plug in -2 into the problem, but I'm telling you right now, it's going to give you +1. And likewise, if I went 1 away here and up in this position, it's going to work. What's the overall pattern? It turns out for parabolas, if the change in here is 1 and it goes up 1, the change in here is 2, it goes up 3. If I change another 1, it's actually going to go up 5. It goes up 1, 3, 5 more every time. It goes up an extra odd number every time. We're going to explore this more in the future, this concept of differences. Anyways, connect the dots, make your parabola. Cool beans. So, if you understood everything on the last test, you can pretty much stop watching the video, honestly. You don't need to finish it off if you don't want to. The reason for that being that, I'm going to finish this up. The rest of the problems here are just review questions, but I'm going to do them here anyways. They're peer review, solved by factoring. Let's see how much we remember about our factoring. So first things first, we're going to go ahead and subtract 2r and add 8 to both sides here. So we got 6r squared minus 2r is minus 12r. And now we have to add 8. If we're adding 8, we're going to get -144 equals 0. Again, what I did there was subtract 2r, add 8. I subtracted 2r and added 8. After that, we ask ourselves, does anything go into all of these guys? And the answer is yes. A 6 comes out. And if I divide 12 by 6, I end up getting 2. And if I divide 144 by 6, I end up getting 24. Please use your calculator if you need help on these ones. After that, we need to go head off to the side and write down the numbers that multiply to 24, and that's 1 times 24, 2 times 12, 3 times 8, 4 times 6, and that's all of them. And they multiply to a negative, and they add to a negative. That means the bigger number is negative. Which one of these adds up to -2 now is this guy right here. And that's pretty much our answer to the problem. R plus 4, R minus 6 equals 0. And therefore R plus 4 equals 0, and R minus 6 equals 0, and R equals -4, and R equals 6. Easy enough. Look at this number 8. I can already tell that this one's going to be long. Look at those big numbers. Maybe you want to rely on our calculator quite a bit here. Excuse me. So we're going to go ahead and subtract n squared on both sides. Subtract 6n on both sides. 41n minus n squared is going to be 40n squared. 294 minus 6 is going to be positive 288. And then another 288 right next door. Now we need to ask ourselves, is there anything that goes into all of those guys? So the easiest way to do this is to use our calculator. I mean, if you can figure out what the number is on your own, that's great. I think it's going to be 4, but I'm not actually certain. But we're going to use our calculator to do it. So we're going to go ahead and hit math, scroll to the right, scroll all the way down to GCD, And then we're just going to type in the two numbers we need, which is 40 and 288. Oh, I was wrong. It's 8 goes into all of them. So I can do 40 divided by 8 to get 5, and I can do 288 divided by 8 and get 36. Let's use a technique that I taught earlier today in the video. I said you could divide everything instead if you wanted to, instead of factoring out. That's what I'm going to do. I'm going to divide every single term by 8. And if I divide every single term by 8, I'm going to get 5n squared here. We just did that, plus 36n plus 36. This is where the question gets more annoying than previous problems, because now nothing factors out with this 5. So we need to multiply 5 times 36 off to the side. Use your calculator if needed. We're going to get 180. And now we need to figure out all the things that multiply to 180. In my opinion, you should stop immediately once you figure out the number that adds to 36. But let's start doing it. 1 times 180, that doesn't work. 2 times 90. 3 times 60. 4 times 45. 5 times 36. Does 6 work? Yeah, 6 times 30. Ooh, we found it right away. So we got our 6 times 30, and we're going to use this number to split this 36n up. I'm going to pause and let people catch up in case they're still writing. Again, what we did was this number here, the 5, times this 36 to get 5 times 36, or 180. We kept on writing all the numbers that multiply to 180 off to the side. If you're struggling with figuring these numbers out, for instance, if you wanted to figure out this 4 and 45, you just do 180 divided by 4, and it will give you 45. Anyways, after I've got this 6 and times 30, I'm going to split that 36n into those two numbers. So we got 5n squared plus 6n plus 30n plus 36. So again, that 36 just became 6 and 30 down here. We divide the problem in two. Ask ourselves what comes out of these two guys, and that's just going to be an n. Ask ourselves what comes out of these two. It's going to be a 6. And now, 5n plus 6 is in both of these, so we're going to pull a 5n plus 6 out. And that still equals 0. Oh my gosh, I forgot my equals 0. Cut from the team. Finishing this off, we have 5n plus 6 equals 0. And we have n plus 6 equals 0. Going to subtract 6 on both sides. Divide by 5. Subtract 6 on both sides. And here are my two answers. One last problem in this video. Number 9. So first we have to ask ourselves, is there anything that comes out of both of these? And the answer is yes, a b comes out. After we figured out that a b comes out, we can immediately go ahead and notice we have a difference of two squares. We have 9 is a perfect square, 16 is a perfect square, b squared is a perfect square. So we can go ahead and write 3b minus 4 and 3b plus 4 equals 0. And now we have just our regular old situation, our zero product property. B equals 0 from here, that guy right there. 3b minus 4 equals 0, and 3b plus 4 equals 0. So 3b equals 4, and 3b equals negative 4, and b equals, divided by 3, get 4 thirds, and b equals negative 4 thirds. And we are finally done with this guy. Good luck on this test, guys, and thanks for watching. Have a great rest of your day, and have a fun October break right when this test is done.